Last lesson, we have introduced the Eurodollar futures. Now let's see how a forward LIBOR term structure can be established from the 3 months forward LIBORs implied by the set of prices of the Eurodollar futures. Let's first draw the timeline. Let Fi denote the 3 months forward LIBOR. Then, the forward LIBOR term structure Si can be retrieved by using the forward rate formula. We'll use the next example to illustrate the detailed calculations. Suppose that the June and September contracts are traded at the futures price of 93.52 and 93.3 respectively, with 92 and 91 days in the respective 3-month period. Obtain the 6 months forward LIBOR from June to September. Since the June contract is traded at 93.52, which implies that the 3 months forward rate from June to September is 100 minus 93.52%, that is 6.48%. Similarly, we can obtain the 3 months forward rate from September to December from the September contract, which is 6.7%. Both rates are annualized. Now let R denote the annualized 6 months forward rate from June to December. We have the following equation. Note that LIBOR follows actual over 360 convention. Solving R from the above equation, we get that the 6 months forward LIBOR from June to September is 6.645%. As we have mentioned in Chapter 2, futures contracts are one of the most common derivatives used to hedge risk. Now let's see how to hedge with the Eurodollar futures through the following example. Suppose today is March the 1st, and we wish to lock in the borrowing rate for a $100 million loan from June to September. The interest payment is payable upfront at the loan date in June, with the loan rate being the then prevailing 3 months LIBOR. The June Eurodollar futures expires on the loan date in June, and its current futures price is 93.33. Can you construct an appropriate hedge to eliminate the uncertainty in the loan rate for the future 3 months loan? In order to lock in the future borrowing rate in June, we take a short position in 100 June Eurodollar futures. Note that the interest payment is payable upfront at the loan date in June, which is exactly the expiry date of the June futures contract. If the futures contract would deliver its underlying asset, we then obtain a $100 million loan at an interest rate of 6.67% for the 3 months period. Assuming the 3 months period has 90 days, the amount of the interest to be paid can be easily calculated as follows. However, in practice, we will borrow at the prevailing 3 months LIBOR in June, which together with the profit or loss from the short hedge in the futures gives us a net effective borrowing cost. The table below illustrates the net borrowing cost with the hedge for a few possible LIBORs at the expiry of the futures. For a given prevailing 3 months LIBOR, the corresponding interest expense can be calculated using the following formula. At the same time, the profit or loss on the short position is also revealed. The net borrowing cost can thus be determined, and we can see that we have successfully locked in a fixed borrowing rate at 6.67% through the short hedge. Next, let's consider the case where the interest is paid in September, that is, at the end of the 3 months period. Can you show that the short hedge strategy used previously no longer works? And can you provide a solution to rectify the problem? First, note that, unlike the previous situation, where the interest payment date matches the settlement date of the profit or loss in the futures position. Here, the interest is paid in September, while the futures expires in June. Due to the mismatch of the timings for the cash flows, the short hedge strategy proposed earlier will no longer work in this case. Now, to rectify the problem, let's assume that on the June expiry date of the futures, if we have a profit, the gain will earn the prevailing 3-month LIBOR from June to September. And if we have a loss in the hedge position, the negative cash flow is paid by a loan with the same 3-month LIBOR as the borrowing rate. Then, we have the following table of the net borrowing cost for the current case with the short hedge strategy proposed earlier. Note that since the loss or gain on the futures are evaluated in September, the figures shown here are obtained from those in the previous table, compounded quarterly using the prevailing 3-month LIBOR in June. A simple and direct adjustment could be short fewer than 100 contracts by using the implied 3-month LIBOR of 6.67% as the discount factor. Assuming that we are able to short about 98.36 futures contracts, the net borrowing cost table would look as follows, where the loss or gain on the futures are adjusted in accordance with the short position of 98.36 contracts. This solution is not perfect, but as it is shown in the table, the net borrowing cost varies not as much as shorting 100 contracts. Up to now, we have finished the part of Eurodollar futures. Next lesson, we will talk about Treasury bond futures.